All right, well, welcome to this evening when we have two special guests from France, and we've enjoyed the French wine, genuinely from France. We have Claude Altayrac and his wife Aline, and they're here from France to Australia, and Melbourne was their second stay. They went for a few days up in Sydney, and then we'll be off to the Red Centre. Then bravely hiring a car and driving out to Goss's Bluff as well, which of course is a very large meteorite impact crater near Uluru in the centre as well. So that should be a big adventure coming up soon. And their skies are probably going to be a lot clearer than what we've got here tonight anyway, and certainly well and truly away from the lights. So they've graciously come down to give us a talk all about the Northern Hemisphere, because of course they are from the Northern Hemisphere. And this is their first time in the Southern Hemisphere?
Yes,
yep.
First.
So first time, and one of the first countries outside France that they've been to as well. So extra special and extra far away, and they're getting used to standing on their head, given that we're upside down here compared to the Northern Hemisphere. So with that, I'll hand over to Claude to speak about the differences between Northern and Southern Hemisphere. And when it comes to question time, so that this actually gets on the recording, I'll use this microphone and I'll bring it round to you at question time. Otherwise, we'll only hear one side of the conversation. You won't hear what the question is unless the speaker actually repeats the question, and then hopefully it will all be on the tape. So I'd like you to welcome Claude, please.
Thank you. I will try to be the most clear as possible, because my English is not perfect. So first of all, I will want to thank Peter to invite us for this presentation. So we are going to see the differences, the main differences between the Northern and the Southern Hemisphere. So I will show you the most important constellations for us in the Northern Hemisphere. And then with these constellations, we will see that for us there is a very useful star. It's called Polaris. Then we will see the iconic deep sky objects we have that and you cannot see, and we will determine by what we don't see, that you have some objects in the sky that we cannot see in the Northern Hemisphere. Donc first of all, the sun's position. We are in Melbourne. The sun for us is very high on the sky, and when we are looking to the sun, you are looking to the north. Of course, we know that you are in the spring, but for us we are in autumn. When you are in summer, we are in winter. So for us, the sun at the same time is there. It's very close to the horizon, and the main difference is when you're looking at the north to have the sun. For us, we are looking at the south. But it could be very impressive, and Peter tell me when you are going to drive, for us we know that you look at the sun. Okay, you're going to the north. But for us, it's not the same. When you have the sun in front of you, okay, you are going to the south. Look, it could be very confusing. The other main difference is the rotation of the sun and the stars. For us, when you're looking at the sun, the stars and the sun going from the right to the left. But for us, Okay. But in the Northern Hemisphere, they are going from the left to the right. And to see that, I will show you a little time lapse. So the south is approximately there. Okay, the stars going from the left to the right. There's many, many planes, of course. And the Milky Way. And for us, it's the center of the Milky Way, very close to the horizon. Then we are going to see the most important constellation in the Northern Hemisphere. In the red circle, there are the constellations that you cannot see. You have Ursa Major, the Big Bear, Ursa Minor, the Draco, and Cassiopeia. I think I saw your sky in the paper. I think you can see Cassiopeia. No? Not really. I don't think so. Okay. And the most important constellation for us is Ursa Major, also known as the Big Dipper, the Great Bear, or the Big Pan. It's very important for us because, first of all, it's very easy to recognize on the sky. We have 7 bright stars, easy to find in the sky, and these constellations never set, so is always visible in winter, in summer, in any seasons. And this constellation is very useful to find other stars in the sky. So this is the lines between the 7 stars, so we can see that it looks like a big pan. So another little presentation. Okay, so you can see the Big Bear, the Big Pan there. We are going to take this curve, and we have this star. This curve is going to this star. This star is, I never remember the name on this star. It's Arcturus. Alpha Bootes. How is the name of the constellation for us? How do you know? How do we say that? Bootes? Boots? Bootes? Okay. And if we continue, take the curve, and we can find another star. This one. This one is Pica, Alpha Virgo. But the most important star, and when we take these 2 stars, drawing a line straight to this one is Polaris. Polaris is the most important star for us. Because Polaris is the closest bright star to the North Galactic Pole for us. It's always indicate the north. And this is the reference star we use to align our telescope to the North Galactic Pole. And it's very useful because where we are in the night and we don't know where we are. you can look at the sky with no clouds, of course. And if we can see Polaris, you see Polaris, you say, okay, that direction is the north, always. That's very useful. So, to align our telescope, we will align the mount on this telescope to the Polaris, near Polaris, not Polaris, but near to Polaris. In fact, we can see Polaris Alpha Ursa Minor. Then the North Galactic Pole is a little bit upper Polaris. And to align the mount, we are going to use the polar finder on the telescope, of course. We are going to use the mount azimuth adjustment and the mount altitude adjustment to point this point, to point the North Galactic Pole. And that's the way we are going to align our telescope. Now, first, we are going to see Polaris on the field of view of the I don't know the term, of the finder. So this is the finder we can see in our telescope. So we put Polaris on the finder. We put Polaris on the center of the finder. Then we are going to move the altitude of the mount to put Polaris on the back. Then we are going to turn the array axis of the mount to put it vertically. Then with the computer mount, we have a little program that gives the Polaris position with the time, with the date, with the altitude that we are. And then, for example, Polaris should be in 3 hours of position. So we put Polaris onto the ring to point the 3 hours position. And then our mount is aligned. So for us, is mount alignment absolutely essential? Depends what we are going to see and to do. I use a little formula for that. With the exposure time, the focal length of the camera, and the camera sensor gives a value k. It's not. It's a simple value. And the camera sensor could be found on the internet. For example, for me, for example, I have a 5D Mark IV, and with this matrix, I can see that the pixel size is 5.4. So it would be my my camera sensor pixel size. So if K is under 200, if Polaris is anywhere on the finder, it should be okay for a good picture. For example, if I want to take a picture with a focal length of 11 millimeters, 60 seconds exposure time, then K should be 122, so it's okay. If I want to take a picture, the last, for example, a focal length of 500 millimeters, 30 seconds of exposure time, the K is 2777. So I would align my mount Polaris should be in the little circle to have a good photo. And to be extreme, if I want to take a picture with my telescope of 1 meter of focal length and 90 seconds of exposure time, K it's bigger, and it's between 10,000 and 20,000. So I would the Mount element could be the most precise as possible. Is it okay for you? So now some deep sky objects. First of all, Andromeda Galaxy. You know it. But for us, it's on the yellow circle. This is a picture I've taken. So as I said it before, for us, Andromeda Galaxy in maybe yes, October, November is just upper for us at the zenith. Looks quite easy to take a picture of it. We have also it's not a globular cluster. Planetary nebula. It's called the Bubble Nebula in the constellation of Cassiope. It should be like this, like a little bubble. Quite easy to see. Another one is the Iris Nebula in the constellation that's called Cepheus. It's dark. It's a dark nebula. So that's a picture that I've taken, but I've got a problem with this picture. You can see the ray of light on the left. In fact, I took it in my garden, and there's some little light pollution in it, and it's the reflection of the light pollution into the telescope. When I saw the first picture, I said, "Oh, okay, that's good." And when I've done the treatment of the picture, I see that ray of light. I say, "Oh, what's a pity. I don't want to take it again." Another galaxy, very good galaxy in our hemisphere, on the big tipper, is the Pinwheel Galaxy. Look like this one. This is quite a beautiful one, because you can see it right, not at the Milky Way, but just upper the galaxy. We have also an open cluster, a beautiful open cluster, a double open cluster. It's called the Perseus double open cluster. Look like this one. There are too many stars in a very little square. Also, we have some dark nebulas, like, for example, the Elephant's Trunk Nebula, near the constellation of Cygnus. Looks like this one. The image is not quite good, but you can see some ray of dark nebula. And this, the star we can see on the left, The red star is the garnet star. Call it the garnet star. Also, we have some very beautiful carbon star, very red star. The most red star in the Northern Hemisphere is a star named S Cephei. Look like this one. Oh, it's not quite red on my screen. Also, we have a meteor shower, a very beautiful meteor shower in August, called the Perseid. Approximately 60 to 100 meteor by hour. Something to looks like this. It's not a real picture, in fact. It's a composition. This picture is a composition of approximately 3 hours of shooting. And as we are in Australia, we have a little galaxy that's called M108. Look like this, and it's kind of a private joke because this galaxy is named after the surfboard galaxy. In the Northern Hemisphere, we usually name galaxies cluster with nicknames. For example, I prefer it's the Nopal cluster. It's called the dancing crocodile open cluster. I don't know why. I don't know why, because I don't know why they call it like this. So now, what we don't see in the Northern Hemisphere. This is the Milky Way. And for us, the center of the Milky Way is approximately 5–10 degrees above the horizon. But it's very close to the horizon. So to take a good picture of it, it's very it's very hard. This picture was taken in Brittany, and the horizon is the sea. That's the best spot we can have to take a good picture of the center of the galaxy. And for you, I think the center of the galaxy should be upper. For us, also, I've never seen small and big Magellanic clouds. So I would like to take pictures of it in the red center. Also, I've never seen Omega Centauri, the biggest open globular cluster in the sky. We have M13, for us the biggest open globular cluster in the sky, but never Omega Centauri. In which constellation which constellation is Omega Centauri? Centaurus. Okay, Centaurus. And that's all. Thanks for the listening. If you have any question, I'll try to answer.
Any questions, anyone? Yeah, Chris.
Thank you, Claude. Thanks for the talk. I was wondering what equipment you use to shoot the deep sky images that you have.
Excuse me?
What equipment, what cameras do you use to shoot your images?
I've got a Canon DSLR. This one, in fact. I use it for astrophotography, to take a picture of the sky, but with or without a telescope. But it could be very it's working very well. And for telescope, I've got a Newtonian telescope, 200 millimeters and 1 meter of length.
And you use the Canon on a T-mount to
Yeah.
on the telescope?
Yes, I mount this DSLR on the telescope. Exactly, not this one, because this one I bring it to make a good picture in Australia. Before I've got a Canon, but it was 70D to take the picture. The pictures that you have seen are taken with the 70D.
Nerida.
Thanks, Claude. I loved your image of the bubble nebula. Did you take that is that a single image, a single long exposure, or was that multiple images that were stacked?
No, I've taken approximately 50 pictures of it, and with a software. I arrange it. I don't know exactly the stack. When it has to stack. I've stacked it.
Yeah, Phil.
Sorry. And how long was each image that you took?
For the bubble nebula, approximately 90 seconds.
It's a shame we don't see that one here. That's really impressive.
How large is it, by the way, compared to the moon?
Approximately two moons. 1 degree of field of view.
Thank you, Claude. When you were in Sydney, just before you came down to Melbourne, I know you didn't have your tripod and you may not have been, you said that you hadn't been looking at the stars, but what could you see differently with your eye? Did you look up? Was it clear while you were in Sydney?
Can you repeat, please?
Okay.
More loudly.
When you're in Sydney,
Yeah.
was it clear skies? Were you able to just use your eye? What did it look like using? It wasn't clear, so
No,
you didn't
it
even
wasn't
get to
clear.
any time. Oh, what a shame.
It wasn't
Okay.
very clear.
Okay, that's one of the
But
questions. Yes.
For one night, but with the light pollution.
Yes, the
it's,
light. I just thought you may have
impossible
seen
to
something.
take picture.
Okay.
Have you seen the Magellanic Clouds yet?
Have you?
Seen the large or the small Magellanic Clouds?
No.
You haven't seen them yet?
No.
It's been raining.
No.
That's a shame.
If it wasn't cloudy out there, you could easily pick them up in that direction by eye.
Okay.
You wouldn't need a camera to even see them. Yeah. Any other questions?
If there was one object from the Southern Hemisphere that you would be able to image, what do you think it would be?
Maybe Omega Centauri. To have it should be very beautiful.
And you know how to find it fairly readily compared to, because it's pretty close to the Southern Cross.
It's pretty close to the Southern Cross. Okay.
Yeah, so if you can see the Southern Cross, you'll normally be able to see it unless it's too low down on the horizon. Yeah. Any other questions for Claude?
How long will you be in Melbourne for? How long will you be in Melbourne for?
We are in Melbourne for 4 days.
4 days.
Yeah.
So are you planning, do you want to come here one night if it comes clear?
No.
No?
No.
You've been too busy?
we have a very great trip to go. We're going to the Great Ocean Road after that, going back to Melbourne for just one night, and then take the plane to the Red Centre.
Right in the Red Centre, you'll be able to see everything there.
I hope.
I was also explaining to Claude and Aline on the way down about the Napoleon Bonaparte connection with the Briars here as well. All right, well with that, I'd ask you all to give our guests a round of applause. Thank you.
Thank you.
Thank you very much.